everyone, I am Arshita from Sri Venkateshwara College of Engineering, pursuing my first semester engineering. Topic Introduction to Mechanical and topic Introduction to IC engines. IC engine Heat engine is a mechanic for converted heat developed by burning fuel into useful work. It can be said that heat engine is equipment which generates thermal energy and transforms into mechanical energy. Each engine can be broadly classified into two categories: external combustion engine, example steam engine, steam turbines, closed cycle gas turbine, etc. Internal combustion engine, example petrol engine, diesel engine, gas engine, etc. IC engines are preferred because of high efficiency, simplicity, compactness, lightweight, easy starting, comparatively low cost. Classification of IC engine. The internal combustion engine is a heat engine that converts chemical energy in a fuel into mechanical energy. IC engines may be classified into several ways. They include, according to the types of fuel used, thermal petrol engine, the fuel used in petrol, diesel engine, the fuel used is diesel, gas engine, the gaseous fuel like natural gas, biogas, LPG is used. Biofuel engine, mixture of two fuels, example mixture of diesel and natural gas, mixture of diesel and neem oil. According to the number of strokes per cycle, four-stroke engine. In these types of engine, the working cycle is completely in four different strokes. Two-stroke engine. In this type of engines, the working cycle is completely in two different strokes. According to the method of ignition, spark ignition engine, fuel is ignited an electrical spark. Comparison, ignition engine, fuel gets ignited by hot compressed air. According to the cycle of combustion, Otto cycle, combustion of fuel takes place at constant volume. Diesel cycle, combustion of fuel takes place at constant pressure. Dual combustion engine, combustion of the fuel first takes place at constant volume and then at constant pressure. According to the number of cylinders, single cylinder engine consists of one cylinder. Multi-cylinder engines consist of 2, 3, 4, 6 or 8 cylinders. Based on opposition of cylinder, horizontal engine, vertical engine, V engine, opposite cylinder engine, radial engine. According to the method of cooling, air-cooled engine, the heated cylinder walls are cooled by continuous flow of air. Water-cooled engine, water is used for cooling the heated cylinder valves. Parts of IC engine. Cylinder, it is the cylinder wells in which the fuel is burnt and power is developed. It is considered as heart of engine. Primary functions of cylinder is to contain the working field under pressure, to guide the piston wheel reciprocating inside the cylinder. Cylinder head, the top end of the cylinder is closed by removable component called cylinder head. The cylinder head consists of two valves, inlet valves and exhaust valve, and the another components like spark plug or fuel injector. Crankcase, It encloses the crankshaft and serves as a sump for the lubricating oil. Crankshaft, sometimes casually called crank, it is the part of an engine which changes the up and down motion of the piston into rotation. To convert the motion, the crankshaft one or more offside shaft piston. The piston is cylindrical shaped component that fits perfectly inside the engine cylinder. Piston ring, the ring which are placed in the grooves cut towards top and the piston are called piston ring. Connected rod, the connecting rod is the link that connects the piston of the crankshaft. Its function is to convert the reciprocating motion of the piston into rotatory motion of the crankshaft. Flywheel is a circular shaped device used in IC engine that stores the engine produced by the engine during power stroke in the from the kinetic energy and provides this energy to be engine during other three strokes. Whereas in IC engine, the device where are used restrict the re-release the flow and inlet fuel and exhaust gases are called engine valves. Four-stroke petrol engine. The working principle of four-stroke petrol engine is based on theoretically Otto cycle, constant volume cycle. Hence, it is also known as Otto cycle engine. Four-stroke engine. The four different strokes are suction stroke, compression stroke, power stroke, and exhaust stroke. In four-stroke petrol engine, consider as PV diagram. AB is suction of air and petrol. BC is compression of mixture. DC is constant volume combustion. DE is expansion stroke. FEB and exhaust valve open. BA is exhaust out combustion product. In four-stroke engine, the four-stroke engine piston perform four different strokes to complete all the operator and working cycle. The four different strokes performed are suction stroke. This stroke starts when the piston is at TDC and about to move downward. During this cycle, inlet valve remaining open, the exhaust valve remains closed. Due to low pressure created by the downward moving piston, the charged air fuel mixture is down into the cylinder. At the end of this stroke, the inlet valve closes. The suction stroke is represented by line AB and PV diagram as shown in figure. These are the four different strokes diagram. Compression stroke. During this stroke, the compression of air fresh down charge takes place by the return stroke BDC to TDC of piston. During this stroke, both inlet and exhaust valves are closed. As the piston moves upward, the air-petrol mixture in the cylinder is compressed adiabatically. The pressure of temperature of the charge increases and this is shown by the curve BC on the PV diagram. When the piston reaches the TDCR just before the completion of comparison stroke, the spark plug ignited the charge. The combustion of the fuel takes place at the constant volume and it's shown by the line CD and PV diagram. The compression ratio in petrol engine range from 7:1 to 11:1. and power stroke. At the beginning of the stroke, piston is in TDC, and during the stroke, piston move from TDC to BDC. During this stroke, both inlet and exhaust valves remain closed. The combustion of fuel liberates gases, and these gases start expanding due to expansion. The hot gases exert a large force on the piston, and as a result the piston is pushed from TDC to BDC. The power complex is transmitted down through the piston to the crankshaft through connecting rod. This causes crankshaft to rotate at high speed. Those work is obtained in this stroke. Hence, this stroke is also called working stroke. Also, gas expand and does work on piston. So, this stroke is also called expansion stroke. The expansion of gases is adiabatic in nature, and this shown by the curve DE and PV diagram. As the piston reaches the BDC, the exhaust valve open. A part of the burnt gases escape through the exhaust valve out of the cylinder due to their own expansion. And last exhaust stroke, at the beginning of the stroke, piston is in BDC, and during the stroke the piston moves from BDC to TDC. During this stroke, inlet valve is closed and exhaust valve is opened. As the piston moves upward, it forces the remaining burnt gases out of the cylinder to the atmosphere through the exhaust valve. This shown by the line EB and BA on PV diagram. When the piston reaches the TDC, the exhaust valve closes, and this completes the cycle. In the next cycle, the piston which is at TDC move to BDC, thereby following fresh charge to enter the cycle, and process continues. And another four-stroke diesel engine, as considering graph, AB suction of air, fresh air, BC is compression of air, CD is constant pressure and combustion, AT at D fuel supplies cut off, DE is expansion stroke, EB is exhaust valve opens, BA exhaust of combustion product. These are the four diagrams for four-stroke diesel engine. Four-stroke diesel engine. The working principle of four-stroke diesel engine is based on the theoretical diesel cycle, hence it is also called Otto cycle engine. They are divided into four stroke: suction stroke, compression stroke, power stroke, and exhaust stroke. In suction stroke, at the beginning of the stroke, piston is in TDC, and during the stroke, piston move from TDC to BDC. During this stroke, the inlet valve open and exhaust valve will be closed. The downward movement of the piston create suction in the cylinder, and the result fresh air is down into the cylinder through the inlet valve. When the piston reaches the BDC, the suction stroke complete, and this is represented by the AB and PV diagram. Compression stroke. At the beginning of the stroke, piston is in BDC, and during the stroke, piston move from BDC to TDC. During this stroke, both inlet and exhaust valve are closed. At the piston move upward air in the cylinder to compress to high pressure and temperature. The compression source is adiabatic in nature, and it shows in by The curve BC in PV diagram. At the end of the stroke, the fuel diesel is separate into the cylinder by the fuel injector. As the fuel comes into the constant contact with the hot compressed air, it gets ignited and undergoes combustion at constant pressure. This process is shown by the line CD on PV diagram. The compression ratio range from 16 is to 1 to 20 is to 1. And power stroke. At the beginning of this stroke, piston is in TDC, and during the stroke, piston move from TDC to BDC. During this stroke, both inlet and exhaust valve is remained closed. As combustion of fuel takes place, the burn goes expand and exert a large force on piston. Due to this, piston is pushed from TDC to BDC. The power impulse is transmitted down through the piston to take crankshaft through the connecting rod. This causes the crankshaft to rotate at high speed. Those work is obtained in this stroke. The expansion of gas is adiabatic in nature, and this shows by the curve DE and PV diagram. When the piston reaches the BDC, the exhaust valve open. The part of burnt gases escape through the exhaust valve out of the cylinder due to the self-expansion. The drop in pressure at constant volume is shown by the line EB on PV diagram. And exhaust stroke. At the beginning of the stroke, piston is in BDC, and during this stroke, piston moves from BDC to TDC. During this stroke, the inlet valve is closed and the exhaust valve is opened. As the piston moves upward, it forced the remaining burnt gases out of the cylinder through the exhaust valve. This shows by the line BA on PV diagram. When the piston reaches the TDC, the exhaust valve closes. This completes the cycle. In the next cycle, the piston, which is at TDC, move to BDC, thereby allows fresh air to enter into the cylinder, and the process continues. Applications of IC engine: power generation, agriculture, marine craft, aircraft propulsion, and automation. Power generation: in power plant, many diesel IC engines are grouped into block called generating unit set. Every engine is connected a shaft that is connected to its electric generator. This generating unit set providing modular electric generating capacity and comes in standardized size ranging from 4 to 20 MW. Agriculture, farm equipment and machinery mechanized at the heat of the agriculture industry. Tractor, planter and combiner are the powered with IC engine to plant and harvest crops. Using IC engines allowed faster production, more food to be grown and harvesting, and superior producer conquering countless tasks. The different tasks are be performed are slowing, welding, harvesting, and threshing, etc. Marine, marine engines or ships are responsible for the propulsion of the wheels from the part to another. The engine used on board ships are internal combustion engine in which the combustion of fuel takes place inside the engine. cylinder and it is generated part of the combustion process. The ships of all types from goods to cars and small boats are run by IC engines. Aircraft propulsion. The IC engine is power plant used in almost all light general aviation aircraft today. Modern aircraft used in the turbo turbofan engine. Electric aircraft motors can be promise a few and a cleaner aviation future, but are still a way of powering prototype automobile. Internal combustion engines are used in almost all automobile or road vehicle like scooters, motorcycles, cars, buses, and highly vehicles. Thank you for watching.